Hi everyone, I'm Andy Hamilton from YUNEX, and with me I've got Gavin Bailey from Aimsun. And I can see it in some of your faces, you're thinking, Andy Hamilton, okay, I'm going to have another Fusion presentation. You're not getting that today. When Darren asked us to do a slot, he talked about collaboration and how we'll work with all the different industry suppliers and partners. So we've just got a few slides today to sort of run through a little bit of how we'll sort of work together in the sort of YUNEX traffic ecosystem, how we can collaborate, and equally then I'll probably give most of the time to Gavin to sort of talk about some of the innovation that we've been doing recently with Aimsun working with Tees Valley and with some of the YUNEX products. A little bit croaky today, so apologies for that, but let's see how the next few minutes go. Okay, this is the most salesy slide I've probably ever had to do, but go with me for now. So to start off with a little bit of, who are YUNEX Traffic? Ultimately, we were Siemens. I think Chris had that on one of the slides earlier. So we were Siemens, carved out a couple of years ago, and we're now YUNEX Traffic. And we've got quite a big presence in the UK. We've got 1,000 sort of employees or thereabouts. A lot of field people working in the field to do the sort of installation of signals, maintenance, all that kind of stuff. We've got our sort of award-winning factory in the UK, where we can manufacture all of our UK products, but also all our global products. So if you think of like the controllers for Germany, for the UK, and for the different markets that they serve, we do all that manufacturing here in the UK, and then we're able to distribute that. In terms of a development team, we've got sort of about 90 engineers, so that will be software, hardware, firmware, sort of covers the full spectrum as such. Mainly based in Poole, but again, some of our teams are around the world. And as you'd expect, we've got support centres and so on that are 24/7, so that when any of our customers do phone in, they're able to get a speedy answer. Now, you might be thinking, what's that rather blurry picture on the right-hand side? That was a lot of years of work, which we were very happy to achieve last month. We had the UTC system going live in London, where there's 5,500 sites connected into our UTC system. And for us, this is the enabler going forward into a Fusion rollout across London is what we want to see. I couldn't not mention Fusion while I'm here, right? But ultimately, so we had that going live last month. We've had TFL were here, and we've done some other presentations, the likes of Intertraffic, about some of this. But yeah, it was a really big achievement for the team and sort of showing that they can deliver at scale, like you sort of said, Darren, thinking about how we can see these wide rollouts. And yeah, this one took a little bit of time, but we got there in the end, and it was nice to see the UTC system being rolled out. So in terms of what do YUNEX actually do, rather than going through all the different portfolio, just sort of say we do a lot of things on street. We do a lot of the systems. So this sort of covers a lot of different areas. We've ultimately, as I mentioned, we've got the UTC systems, we've got the UTMC systems. So if you want to do that strategic traffic management side of things, we'll do the equipment on street, so the controllers, the signal heads, and all of that. We also work with the likes of Aimsun to do sort of simulation offerings. So we've got quite a broad portfolio is a fair thing to say, but yeah, I'm not going to go through all of these. The main thing that I wanted to really, I've only got one more slide, believe it or not, before I hand over, is kind of talking about how do we collaborate then? Because as I say, we've got quite a big offering, I like to think, I hope. And then equally, we want to say that we also work with lots of others. It's not just our kit that's out there. We also collaborate and work with different suppliers for the hardware and for the software side of things. So just sort of going through this ecosystem. And yes, I had a little bit of fun with Copilot trying to come up with some new icons. I thought I was actually quite impressed when you just sort of generate me some different product views. But anyway, so Stratos is our UTMC system, where you've got the likes of Strategy Manager, environmental monitoring, or journey time analysis, all of that kind of thing. So that's been in the market for sort of over 10 years now, and it had its predecessors as well. But yeah, Stratos is used by I think over 70 customers in the UK. Hopefully I'm right. I got a thumbs up, I think. So yeah, something to that effect. So it is well used out there, and obviously that continues the investment in the product to take it forward. InView is our fault management system. So, if there's issues on street and you want to manage the traffic engineers to get someone out to fix it, or the field operatives out to fix something, then you can use InView to do that. In terms of UTC, Chris was sort of talking about that, obviously from the TRL point of view. It's the second-by-second control, right? It's the auditing, it's the communication with the infrastructure on street. It's the control as well, so actually sending the control bits down to say this is when you should change your signals. And ultimately now for us, this is where we've got Fusion. This is the sort of the brain of the system, the sort of the real-time control, making sure you've got coordination across your network. And as I say, with London now, with that sort of UTC system going live, that gives us that enabler to see a wider rollout. And again, we're chatting to a number of different people in this room and sort of seeing hopefully that wider rollout for Fusion across the UK and global markets. We're trying to make that integrate not just for the UK technology stack, we're also looking at it in an international way to again get that feedback and bring that features from all over the world and how we can enhance that going forward. So that's great. That's me talking about us again. How do we actually collaborate? So just a really simple diagram to kind of emphasize. So we did get permission to show a number of different user logos here, or different suppliers out there. So in terms of the on-street equipment, again, that's a variety of equipment that's out there in the market, where you've got, might be VMS type signs, might be car park information, could be environmental monitoring for the likes of EarthSense, getting that real-time sort of enhanced detector data with the likes of VivaCity or Starling, bringing that information into our system. And there's a little icon at the bottom, sort of other third parties as such. So how do we enable that? And without going into loads of detail, ultimately we use standards that are out there in the market that will be UTMC standards, it'll be UG405 if you're thinking that real-time communication. And it's not just about the sort of not legacy, but current standards that we have. It's also about collaborating and working with other suppliers to develop the next generation of standards. So again, working with a number of people that are in this room to try and shape the likes of the Topaz spec, 2545 to get that richer detection data coming into our central system. And when we have, standards in place and sort of shaping the future ones as well, that means that, we can be interoperable. It creates that open market and competition is available. And, we completely support that and are in a lot of the different groups that you'd expect. On the other side, so not just the on-street equipment, we also think about, the different data providers and the consumers that are out there. We'll hear from Aimsun in a moment, but again, there's lots of different use cases, and I didn't want to sort of go through lots of slides today running through them all. We think it could be bus priority integration, bringing that information in from ticketing companies. It could be disruptions that are on the network, how that feeds into that sort of central ecosystem so that you can automatically respond to incidents. It could be getting journey time information from floating car data, for example, and just bringing that into the system to do something a little bit different. And so this is where, again, looking at the standards that are there, you've got UTMC. We've had a little bit of mention of that from Darren earlier, and what that maybe the next step of UTMC looks like. And again, we're in those conversations trying to help work with, other suppliers and the market to try and shape, what does the future look like? How do we make sure this is robust in the collaboration and you have that sort of complete ecosystem available? But yeah, we've got the sort of existing UTMC standards, but also the Datex 2. We publish, faults, disruptions, journey time information, all of that out of our ecosystem. So I think when the challenge from Darren was, how do we collaborate? We collaborate with lots of different suppliers, as I say, lots of the people that are in the room, and we sort of do that through standards and shaping the next generation of standards as well. So that's really important for us because then it saves the local authorities money, it saves the suppliers money, that ultimately you're not creating lots of proprietary interfaces throughout the sort of ecosystem. So yeah, that's very much our aim for the standard side of things. And so that you don't have me speaking the whole time, I'll be able to hand over to Gavin and he can take us through some of the sort of innovative work that we've been able to do with Tees Valley, and it's an active project, again working with the current systems that are there. So thanks very much.
Right, hello. So Thank you, Andy. Gavin from Aimsun. I'm going to take you through our Tees Valley system, which we've just kind of started developing, and use it as kind of a way to demonstrate some of the applications for our traffic digital twin technology. So Tees Valley, this is the project started with Tees Valley Combined Authority, and it's really being delivered through a partnership between Tees Valley Combined Authority and Middlesbrough, and it's to deliver a digital transport solution across the entire authority, all 5 authorities, so Darlington, Stockton-on-Tees, Hartlepool, Middlesbrough, and Redcar and Cleveland. Tees Valley is quite an important area. It's a very fast-growing economy, currently worth a little over 3 billion, and it presents a fair few transport challenges, being that it's got an international airport, it's got a deep water port, and you've got a number of kind of fast connections down to London. They've got fairly kind of big ambitions to deliver a kind of futuristic transport system through their digital transport strategy, which we're hopefully going to play a part in, helping to deliver. So traffic digital twins, I'm sure that everyone's fairly fed up of the term digital twin. I think the problem in this comes that it's a fairly diverse term, and it's really important to contextualize what these mean. When we're talking about a traffic digital twin, we're talking about a system which is a digital replica of a road, pedestrian cycling infrastructure, and it's connected to real-world sensors taking, so automatic traffic counters, mover detectors, computer vision based traffic detection, mobile phone data, any kind of other floating car data. We're taking that data in real time, processing it into the digital environment, and you can actually see dots moving through the digital system in real time or near real time, which represents the traffic flow. Using AI techniques, so largely machine learning, pattern matching algorithms, we are able to simulate real-world traffic and also simulate and predict traffic up to an hour ahead of time on a rolling time horizon, which really gives the sitter to inform decision-making and to proactively manage the road environment. One of the key things with our system, particularly in Tees Valley, is the ability to consume data from a myriad of sensors, in this case using YUNEX to kind of consolidate this and feed it through to us. And then add intelligence, add simulation, enable users to code response plans. We use AI to improve situational awareness of traffic managers, to decrease the cognitive load that they experience in their day-to-day work, and actually then simulate potential traffic management actions on the network, evaluate the most appropriate ones or the ones that are likely to be the most effective, very quickly identify the best solution out of those, and then actually trigger those and send an instruction back to YUNEX system so you can actually actuate change from the digital twin. So it gives you that kind of one portal through which you can actually view the network and manage the network. So just to go over some of the kind of key functionalities of the Tees Valley system. Now, it's currently under development, and we're currently consuming data, and we're actually training the AIs. The AI specifically responsible for incident detection. So hopefully, maybe in September, we'll have something which is operational. So I'm going to use the example of Oxford. Don't worry, you've not all gone back in time and you're experiencing deja vu here. Our incident detection system constantly monitors traffic flow over detectors, and it monitors it in relation to the trends, the historical trends that it's identified. And when there's a significant drop in traffic flow over a detector, it can then trigger a alert to say there's something going on in the network here, you should probably investigate. Once a operator confirms the incident using CCTV, or you could have this automated using computer vision CCTV cameras. They can then very quickly go to manage the network, and they can code in bespoke plans on the fly, or in this case, they can actually go and they can select pre-coded plans to manage recurrent congestion events or incidents. And then they get, once it simulates the solution, so you can simulate up to 3 response plans in addition to the do nothing, provides visual information to show how the network responds. It also evaluates the health of those solutions against KPIs and then can provide in graphical form. So it's all designed to provide very quick, understandable information to operators so that they can quickly identify the most appropriate action plan to manage the network and mitigate congestion. And they can cycle through the kind of evolution of these incidents and these response plans up to an hour ahead, so they can use the predictive engine as well. In a similar way to the way the incident detection works, our bus reliability tool pulls live bus data and compares the location of buses against the bus timetable to identify whether there's a bus that's late or likely to become late based on its simulated movement through the traffic network. And then in a similar fashion to what I just showed you on incident detection, operators or traffic managers can then simulate pre-coded response plans or code something up themselves. But in this instance, it's more likely to be a pre-coded response plan to give a bus priority along a corridor, assess the impacts of that plan on the wider traffic network to make sure that you're not detrimentally impacting the wider traffic network and causing unwanted congestion, and then identify the best solution and go to implement it. So, in Tees Valley, what's next? Well, as I said, we're currently in the process of assessing the data, training the machine learning tools to actually deploy incident detection. And hopefully September, a bit later this year, we'll have something which we can actually show, which is operational. But this is just this final slide is just to impress upon that this is really a tool, and it's not something which they can be. Digital twins or AI are not the end goal. They're an enabler to what you want to achieve. So here we've got examples of it being deployed in Oxford for air quality management and avoiding emissions exceedances. Under tests, we found that we actually successfully identified 65% of days. We identified kind of response plans to avoid emissions exceedances on 65% of days when there would have been an exceedance. We're deploying them in China, Abu Dhabi, so very much international. We've got deployments in Australia and also the US for incident management and a myriad of other applications. And of course, we're working closely with autonomous vehicle manufacturers and the insurance industry to help them compile an evidence base for the risk factors related to autonomous vehicles. So we're applying it in a research and development context to help the industry in future transport as well. That's it from me. Thank you very much.